the last part of the heart of algebra is going to be solving linear equations. Then we're going to go into solving linear systems, and then we're going to look at some linear inequalities. So this is the very last part of the heart of algebra. Okay, so solving linear equations, this should be a review for you guys. It says we can solve linear equations algebraically, that's by hand, or with our graphing calculator, which I'm going to show you that, by graphing each side of the equation and finding the intersection point. Okay, so first let's do it by hand. So it says solve the following equations. 3x minus 1 equals 5. Okay, this is a review. I'm not going to spend too much time here. We'd add 1 to both sides. That would be 6. Then we have x equals 2 here. So there's our solution. Okay, for the calculator, what we're going to do is we're going to graph both sides of the equation. So turn this on, go to y equals, we're graphing 3x minus 1. Then we're also graphing the other side of the equation, which is 5. But you guys should know what 5 looks like. That's going to be a horizontal line through 5, okay, because the slope is 0 here. Also go ahead and go to second, y equals, turn off your stat plot if you have it on. Okay, if it is on, it probably won't graph these. I'm going to go ahead and change the window to -10 to 10, so standard window, and -10 to 10. Alright, graph this. Alright, so there's our 3x minus 1, which we could have graphed by hand. Okay, y-intercept minus 1, slope 3, so up 3 over 1. And here's our y equals 5. Okay, that's our constant function. Okay, so what we're doing is we're finding the intersection point. So where does 3x minus 1 equal 5? Okay, so remember how to find intersection points. We go to second trace, go down to intersect. Okay, first curve, second curve, it jumps to our second curve. Now we're telling the calculator to guess, and it brings up exactly x equals 2. Okay, so this is one of the reasons why having a graphing calculator for the exam is really good. This one is pretty simple to solve. Once we get into quadratic equations, polynomial equations, rational equations, okay, they take more time to do by hand. But if you have a graphing calculator, you can graph both sides of the equation, and it'll give you the solution quickly, and it's accurate. Okay, number 2, I'm just going to finish solving these by hand. You could easily graph -4x minus 6, graph 2x, find the intersection point. Like I said, I think it's faster to just do it by hand here. So we first need to get all the x's together, so I'm going to add 4x to both sides. This would be minus 6 equals 6x. Then divide by 6 on both sides, which I'll go ahead and write out. So x equals -1. Okay, and then number 3, we have -x plus 4 equals 3x plus 12 minus 5x. Okay, again, you could graph both sides of these equations, of this equation, find the intersection point. Okay, so I'm going to go ahead and simplify first. I'm going to go ahead and distribute the negative to both of these. This would be minus x minus 4 equals. We can also combine the 3x and the minus 5x, so this would be minus 2x plus 12. Now I'm going to finish solving. I'm going to bring the 2x over. So this would be x minus 4 equals 12 is what we have left. And then add 4 to both sides, so x equals 16, and we're done. Okay, again, you could do this with your calculator, get the same solution. Okay, moving on to page 23, we have solving systems of linear equations. Okay, so it says a system of linear equations is a set of 2 or more linear equations. We will solve systems with 2 linear equations. On the SAT, I have seen some with 3, okay, but normally the third one is a pretty simple one. Okay, so we won't focus too much on 3, but normally your linear equations have linear systems have 2 linear equations. So that's what we're going to focus on. Okay, so what we're given with a system is we're given 2 lines or 2 linear equations, and we're wanting to find their intersection point. Okay, so there's 3 types of answers to these systems of equations. The first one, which is the most common, is one answer. Okay, so for example, you're given 2 lines, which that's not straight. Let me straighten that up. Okay, so let's say you're given this line and this line. Okay, here's your solution. You have one intersection point. Okay, as long as you're given two lines, that's all you can have if you have an intersection point, is just one solution. Okay, it's not going to curve back up and give you two solutions. Number 2, you have no solution. Okay, so we might be given something like this. So here's a line, here's a line. Okay, if you have two lines with the same slope, that means they're parallel. So parallel lines have the same slope. They don't have an intersection point, which you can see. So this would be no solution. And then number 3 is infinite solution. You have two lines that are the same. Okay, so you would just have, when you would graph this, if you graph to find the solution, you would just have one line here. You have infinite amount of solutions, okay, because the intersection point is actually the whole line. Okay, so infinite solutions. By far the most common is number 1, one solution. Okay, bottom of page 23, it says decide what kind of solution the systems of equations will have. We're not solving these, we're just trying to find the solution. Okay, so what I'm going to do is I'm going to put this in the linear form that we're used to, the point slope form. So solve for y for both of these, and then we should be able to see if they're different lines, if they're parallel lines, or if they're the same line, and that'll give us what type of solution we'll have. Okay, so I'm just going to come over here, I'm going to come to this side, and I'm going to do this 5x plus 2y equals 6, solve for y here. So subtract 5x on both sides. So 2y equals 6 minus 5x. Then we'll have y equals 6 minus 5x over 2. So y equals 6 divided by 2 is 3 minus 5/2 x. Now I'm going to do the next line. We have 4x plus 6y equals 7. Solve for y. So 6y equals 7 minus 4x. Divide by 6. This would be 7 minus 4x over 6. So y equals 7/6 minus 4 over 6x, or 2/3 x. Okay, so you guys can see, which I'll go ahead and copy these again. Y is 3 minus 5/2 x, and you have y is 7/6 minus 2/3 x. Okay, so these are completely different lines. They have different slopes, they have different y-intercepts, so we would have something that looks like this. So two completely different lines, you're just going to have one solution. They do have to intersect since they have different slopes. So this would be one solution. Okay, bottom of page 23, I'm going to do the same thing. So I'm going to put a line here. So I'm going to do the first one, 2x minus 6y equals 7. So solve for y. This would be minus 6y equals 7 minus 2x. Divide by negative 6. 7 minus 2x over negative 6. So y would be negative 7, 6 plus, I'm going to go ahead and reduce. That would be 1/3 x here. Okay, the next line we have 3x minus 9y equals 10. So this would be negative 9y equals 10 minus 3x. Y equals 10 minus 3x over negative 9. Y equals negative 10/9 plus 1/3 x. Okay, so this line over here is the same as y equals negative 7/6 plus 1/3 x. This one is y equals negative 10/9 plus 1/3 x. Okay, notice something for both of these, m equals 1/3. Okay, so you have two different lines. Okay, they're different because these numbers are different. The y-intercepts are not the same. Okay, so you have one intercept here, one intercept here, but the slopes are the same. So you have parallel lines here. We put parallel. Okay, when you have parallel lines, they're never going to intersect, so this would be no solution. Okay, on to page 24, we have one more. Okay, 4x minus 6y equals 1, 6x minus 9y equals 1.5. So we're going to do the same thing here. So 4x minus 6y equals 1. So solve for y. Minus 6y equals 1 minus 4x. Y equals 1 minus 4x over 6. Y equals 1/6. This would be minus 2/3 x, so reducing there. Next line, we have 6x minus 9y equals 1.5. Let's go ahead and get rid of that decimal. Let's multiply everything by, if we multiply everything by 10, that should give us, get rid of that decimal, which you don't have to do that, but I just don't want to work with decimals. So 60x minus 90y equals 15. Okay, if you multiply everything by 10. Okay, so solving for y, this would be minus 90y equals 15 minus 60x. Y equals 15 minus 60x over negative 90. I believe this is going to be the same line. Yeah, so this is minus 1/6. This is minus 2/3. This is plus 2/3 x. Let me check that. I thought I set this up to be the same, so let me check. Did I make a mistake here? Oh yeah, so this needs to be minus 6 here. The first one I made a mistake in. Okay, so notice these are the exact same lines. I'm just going to put minus y equals minus 1/6 plus 2/3 x. Okay, so they're the same line. So you would have infinite solutions. Okay, so next we're going to go into actually solving these. Okay, so it says there are 3 ways to solve systems of equations. Number 1 is graphing. So you're going to graph both lines and find the intersection point. Okay, we've done that numerous times. Okay, this is probably the most time-consuming way, so we'll just do one example and then we'll move on. The second way is substitution. So it says solve one equation for y. Plug the solved equation into other equation and then find x by solving. Okay, that's pretty time consuming also. I like number 3, elimination. That's what I always use to solve systems. So you line up the x's and the y's, multiply one, both, or none of the equations by a number to get the x's or y's the negative of each other. Add them together and solve. Okay, so this one will be easier to explain as we do it, but this way is probably the fastest way. Okay, so we're going to do an example of each one of these. So the first example says solve the following system using the graphing method. So we're just going to graph here. Okay, so first of all, we have 3x equals 3y, y plus 2x equals 3. Let's go ahead and put each of these into the y equals form. So 3x equals 3y. Solve for y, so divide by 3. That would actually just be y equals x. Then we have y plus 2x equals 3. Solving for y, this is 3 minus 2x. Okay, so this first line you have the slope is 1, y-intercept is 0. This line you have the slope is negative 2, y-intercept 3. Okay, I'm going to try to be really accurate with my graphing here. Okay, the graphing method, especially if you're doing this by hand, you don't have a graphing calculator, this can be tricky because you need it to be exact so you can see the point where it intersects. Now, if you use a calculator, it's pretty easy to do. You would just graph y equals x, y equals 3 minus 2x, and then find the intersection point. Okay, but I'm going to assume you don't have a graphing calculator, so I'm going to try to be as accurate as possible, make the tick marks exact. Okay, so we have first one, b equals 0, slope is 1, so that means rise 1, run 1. Okay, so there's y equals x. Then we have y equals 3 minus 2x, y-intercept is 3. I don't know why I did that. Over here, the slope is m, is negative 2, b is 3. Okay, so 0, 3, so 1, 2, 3. And then our slope is negative 2. So we have rise, negative 2, run 1, which actually works out perfect. So you can see that this is our intersection point. This is the solution. So our solution is, what is that, 1, 1. Okay, so for all of these, your solutions are going to have a point. Okay, if there is a solution, it's going to say, you know, x, y, something like that. Okay, page 25 says solve the following system using the substitution method. Okay, so the substitution method says solve one equation for y, okay, which we can easily do. So I'm going to go ahead and solve this first one for y, just because it's first. It looks like it's easy to solve for y. That's y equals 90 minus x. Okay, then what we're going to do is we're going to plug this in for this. So we're going to plug in 90 minus x for y. Okay, so we have 2 times our y, which is 90 minus x. Okay, so that's what I did here. 2y is there. Okay, minus x equals negative 6. Okay, now we're going to solve for x for this. So distribute the 2, that is 180 minus 2x minus x equals minus 6. 180 minus 3x equals minus 6. Subtract 180 on both sides, that would be minus 3x equals minus 186. Divide by negative 3x is 62. Okay, we're not done yet. Okay, that's just our x value. So we still have to find our y value, which we'll use here. So y is 90 minus x, which we knew our x is 62. So 90 minus 62 is 28, right? I want to check though. Yeah, 28. So y equals 28. Okay, so our solution is xy, so 62, 28. Okay, so that's one way to do it. This one actually worked out nicely because this equation was simple. Okay, but if you come down and look at this next one to solve for y, for this first one, it's not going to be as simple. It still is decent, but not as simple. A lot of students like this way the best, which is perfectly fine. Okay, I like the elimination, which I'm going to show you next. Okay, so it says 2x plus y equals 1, and then we have negative 4x plus 4y equals 6. Okay, so what I like to do is I like to get these x's, which they're already lined up, okay, and they just need to be opposites of each other. So I'm going to make this 2x into a positive 4x. Okay, so I'm going to multiply this whole thing by 2. Okay, which gives me 4x plus 2y equals 2. Okay, so you have to multiply everything by 2. I'm going to leave the second one the same. So negative 4x plus 4y equals 6. Okay, now when I add these together, 4x plus minus 4x is 0, goes away. Okay, so that's why I did that. So you want to get the x's the same constant but opposite of each other. So like 6x and negative 6x, or 10x and negative 10x. Okay, now we have 2y plus 4y is 6y, and then 6 plus 2 is 8. Okay, so then y is 8 over 6, which is 4/3. Okay, so there's our y. Now we need to find our x. I'm just going to plug it back into this equation. So we have 2x plus y equals 1. I'm plugging in the y plus 4/3 equals 1. Okay, you can go ahead and solve through, I believe it is negative 1/6. So go ahead and check that. I have the solution. Let me just quickly check that in my calculator. Yeah, that's correct. Okay, so there's our solution. Okay, again, this is my favorite way. I'm going to do the rest of them like this, but you can use any of them. Okay, next example, solve the following system using any method. Okay, again, I'm going to use elimination. So here I'm going to multiply again by 2, which I should have changed up x's. So this is 4x minus 6y equals 2. And this is minus 4x plus 6y equals 5. Okay, so add these together. That is 0. That is also 0 equals 7. Okay, so the equation we have is 0 equals 7. This is not true. This is false, right? 0 is 0, not 7. So since this is false, this gives us no solution. Okay, so if you would have instead did the y's, you would still get no solution. You would have 0 equals something. So if you check this, you'll see that the slopes of these two lines are the same. They're parallel lines, so no solution there. Okay, page 26. Okay, solve the system using any method. Again, I don't know why I didn't choose different x's here. Okay, so again, multiply by 2. This would be 4x minus 6y equals 2. This is 4x plus 6y equals negative 2. Okay, add this together. This would be, oh, sorry, negative 4x. 0, that's how I set that up, plus 0 equals 0. Okay, so now we have 0 equals 0. This is true. So it doesn't matter what you would plug in, you're always going to get a true here. So this is actually infinite solutions. Okay, if you would have done substitution, you would have got the same answer. If you would have graphed it, you would have saw that it's the same line, so it would have been infinite solutions. Okay, and then the last thing we're going to do with graphing is graphing inequalities. Okay, so it says graph the line as if they were an equal. Okay, so inequalities are something that looks like less than, greater than, less than, equal to, or greater than or equal to. So how do we graph these? So you graph the line as if they're an equals there instead of one of these. Draw a solid line if the inequality is less than or equal to or greater than or equal to. Draw a dotted line if the inequality is less than or greater than. And then third, shade above the line if the inequality is greater than or equal to. Shade below if it's less than or equal to. Okay, so we use a solid line if it's an equal, and we use a dotted if it's not. Okay, if it's greater than, we shade above. If it's less than, we shade below. Okay, so it says graph y is less than or equal to negative x plus 5. Okay, so we first graph it as if there were an equal sign there. Okay, so this is slope negative 1, y-intercept 5. Okay, so when we graph this, we'll graph 0, 5, and then our slope is negative 1, so down 1 over 1. So rise over run, don't forget. Okay, I'm using a solid line here because it's or equal to. Now if that or equal to was gone, I would have made this a dotted line instead. Okay, it's less than, so we're going to shade below the line. So everything below the line. So, and this would be an infinite shading too. We're just going to shade our picture though. If it was greater than, we would have shaded above. Okay, number 2, graph 2x minus y greater than 3. Okay, again, we're going to graph this like this were an equal sign. So 2x minus y equals 3. Solve for y here, so minus y equals 3 minus 2x. Divide by negative 1, y equals, that would be minus 3 plus 2x. Okay, so your slope is 2, y-intercept negative 3. This picture is going to be a little smaller. Okay, so we go down 3. There's our y-intercept. Slope is 2, so up 2 over 1. Okay, now we need to look and see if this is solid or dotted. You don't have the or equals to, so this is going to be dotted. Okay, now here's where it's tricky. This is a greater than, okay, which I should have left this as a greater than, which I'm going to do. So we have greater than here. Okay, so you have negative y greater than here. Okay, now when we divide by negative 1, okay, when you divide by a negative number with inequalities, it changes the sign, so you actually have a less than. Okay, so just be careful with that. That should be your review also. Okay, so you may want to go back over that. So we're going to shade below. Okay, so shade below the line. Okay, and then one more. Page 27. So it says graph 6x greater than or equal to negative 8 minus 3y. Okay, so again, we're going to solve for the negative 3y. Let's do plus 8 on both sides, so 6 x plus 8 greater than or equal to negative 3y. Okay, now we're dividing by a negative. Remember, when you divide by a negative number, switch the sign to less than or
equal to y here. Okay, putting y on the correct side just because I like it on the left. I'm just going to rewrite this whole thing. This says y. This is y greater than or equal to. And then we have 6x divided by negative 3 is minus 2x, and then this would be minus 8/3. Okay, so there's that picture. Okay, so we're graphing minus 8/3 first, which is our y-intercept. Okay, so minus 8/3 is about 2 2/3, so here. And then our slope is down 2 over 1, so about here. And then it's y is greater than or equal to, so we're doing a solid line. Since it's greater than, we're going to shade above. Okay, next we're solving systems of linear inequalities. Okay, this is kind of like what we just did. So we had systems of linear equations where you have an equal sign. But now we're doing inequalities. Okay, so how to solve those, we just have one way of solving. You graph all the inequalities. The solution is part of the graph that is shaded with all of the inequalities. Okay. So we're going to graph both of these in this example. We're going to do our shading, and then where the shading intersects, that's our solution. So we actually have a solution set. Okay, for equations, we had 1 point as our solution. For this, we have a solution set. So you have actually infinite amount of solutions. Okay, so this first one, y less than or equal to negative 2x plus 1. Our slope here is negative 2, y-intercept is 1. For this one, slope is 1, y-intercept negative 4. So let's go ahead and graph those. I think if we go out 4 each way, it should be plenty. So the first one, y-intercept 1, slope is negative 2. So this would be the first one. Okay, the first one is less than or equal to, so we're going to do solid line. And it's less than, so we're going to be shading below. Okay, so I'm going to do this lightly. So here's our shading for the first one. So we've graphed the first inequality. Now the next inequality, y greater than or equal to negative 4 plus x. So we have b is negative 4, and our slope is 1, so up 1 over 1. Okay, now it's just greater than, so we're going to use a dotted here. Okay, and it's greater than, so we're going to actually shade above. Okay, so again, I'm going to do lighter here. Shading lighter than I was on the previous ones. Okay, and you guys can see where the solution set is. So we shaded this section here twice. Okay, so here's our solution. Okay, so it's actually not, we can't write one solution. It's actually a solution set. So any of these points would satisfy those. Okay, so you could take this point. Okay, it's going to satisfy both of those. You could take this point. It's going to satisfy both of those. You could take this point and this point. Okay, so anything in that shaded section is going to satisfy that. Okay, number 2, we're going to do the same thing. So let's solve for y in all of these first. Okay, so this 2x minus 3y is less than 6. So we have to solve for y, so minus 3y is less than 6 minus 2x, divided by negative 3. Okay, so this turns to y greater than. So 6 minus 2x over negative 3. So y is greater than negative 2 plus 2/3 x. Okay, the second equation, x plus 4y is less than 16. We have 4y is less than 16 minus x. Divided by 4, y is less than 16 minus x over 4. So y is less than 4 minus 1/4 x. Okay, this last one you don't have a y, okay, which we'll go over what that means in a second. This first equation you have m is 2/3, b is -2. The second one you have m is -1/4, b is 4. Okay, so I'm going to draw a smaller graph here. I think again if we go out by 4 it should be plenty, hopefully. Okay, so the first line we have y-intercept -2. Our slope is up 2/3. It's greater than or equal to, so we're going to do dotted. And it's greater than, so we need to shade above. Okay, the next line is b equals 4. And our slope is -1/4, so down 1/4, 1, 2, 3, 4. Okay, and it's also just less than, so we just want to do dotted. And it's less than, so we're going to be shading below. Okay, so far, you guys can see for the shading, it's this section here, but we have one more to graph, which is this x greater than 1. Okay, remember if you don't have a y, that means it's a vertical line. Okay, so vertical line, and it goes through 1. Okay, so we're going to have a vertical line. It's going to be dotted because we don't have the or equals to. So it's going to be a vertical line through 1 here. And it's greater than 1, so we need to shade to the right. Okay, we don't have above or below, but just use what you guys know. If it's greater than 1, you're going to have to be shading this way. So you're shading this way. Now what solution set has shaded all 3? It looks like this section here. Okay, so any point in this little triangle here would satisfy all of those 3. Okay, we're going to stop there, and we just have, I believe, 2 more pages left that will end the Heart of Algebra, okay, where a lot of your questions are coming from the Heart of Algebra on your SAT. So we're almost done with a big chunk of learning what's on the SAT. So the next part, we're just going to do some word problems, and then we will be done.